Hello viewers, welcome to the channel Amazing Civil Engineering Studies. In today's video we are going to discuss about stress-strain curve, stress-strain diagram. The stress-strain curve is a graph that shows strain increases. It is a widely used reference graph for metals in material science and manufacturing. There are various sections on the stress and strain curve that describe different behavior of a ductile material depending on the amount of stress induced. Stress and strain curves for brittle, hard, but not ductile, and plastic materials are different. The curve for these materials is simpler and can be learned very easily. We shall focus on the stress-strain curve of ductile materials. But before we delve deeper into that, let's take a look at another important concept: Hooke's law. Hooke's law. Hooke's law states that the strain of the material is proportional to the applied stress within the elastic limit of that material. Mathematically, Hooke's law is commonly expressed as F equals K X, where F is the force, X is the extension length, K is the constant of proportionality known as spring constant in N/m. Stress-strain graph. It's a graph which represents stress value against strain value of a given material when the material is subjected to increasing pull. There are mainly 6 points in the graph: proportional limit, elastic limit, yield point, ductile point, ultimate point, point of rupture. Proportional limit. It is the region in the strain curve which obeys Hooke's law, i.e. within elastic limit the stress is directly proportional to strain produced in the material. In this limit the ratio of stress with strain gives us proportionality constant known as Young's modulus. The point in the graph is called the proportional limit. Elastic limit. It is the point in the graph up to which the material returns to its original position when the load acting on it is completely removed. Beyond this limit the material cannot return to its original position and a plastic deformation starts to appear in it. The point A is the elastic limit in the graph. Yield point or yield stress point. Yield point in a stress-strain diagram is defined as the point at which the material starts to deform plastically. After the yield point is passed there is permanent deformation develops in the material and which is not reversible. There are 2 yield points and it is upper yield point and lower yield point. The stress corresponding to the yield point is called yield point stress. The point B is the upper yield stress point and C is the lower yield stress point. Ultimate stress point. It is the point corresponding to the maximum stress that a material can handle before failure. It is the maximum strength point of the material that can handle the maximum load. Beyond this point the failure takes place. Point D in the graph is the ultimate stress point. Fracture or breaking point. It is the point in the curve at which the failure of the material takes place. The fracture or breaking of material takes place at this point. The point E is the breaking point in the graph. Thanks for watching. For now, please subscribe, like, share and do not forget to press bell icon.